Good afternoon, ninth graders. Today in science class, we're going to talk about some weather things, specifically tsunamis. So what are some things, we're going to start by filling out a KWL chart about tsunamis. So what are some things that we already know about tsunamis?
I think I know that tsunamis are in water.
Okay.
Is that right?
Yeah, I think they're in water. They're also big waves, right?
Mm-hmm. Yeah, I think waters are really big waves, or tsunami water.
What do we want to know about tsunamis by the end of this lesson?
I want to know how they happen.
Okay.
I think I also want to know, like, if they can happen in like a lake or a pond, or if they happen to have to happen in the ocean.
Okay.
Maybe can they happen in small waters? Thinking.
Can they happen in small bodies of water?
Yeah.
Okay.
Could it happen in the pond in my backyard, I wonder?
I'm not sure, but maybe we'll find out.
Yeah, we're gonna find out.
Okay, another thing that we're going to do today is we're going to talk about an experiment. Mm-hmm. So, what are some things that we know about an experiment, about how an experiment works?
So we haven't talked about that in science a lot.
Yes.
I think an experiment is done by a scientist.
Okay.
And I think an experiment is also something you have to plan for. You can't just grab a bunch of stuff and do it. You have to write up a plan.
It has to be planned.
Yep.
What do we want to know about an experiment? What are all the steps?
Yeah.
You know, include?
Yeah. What are the steps to an experiment?
Alright.
Maybe why do we do experiments?
Okay. I do them. Okay. Those are my questions about experiments.
So now we're going to try to learn a little bit more about tsunamis. Since we asked our questions, I thought I would show you a few different pictures of places where tsunamis could happen. So if you would look up on the smartboard, I'm going to show you two different pictures of places where tsunamis could happen. And we said that tsunamis have to happen in a body of water. And the first place it can happen is in an ocean here on the left. Has anyone ever seen an ocean before? I think you probably have, maybe in a picture. And then on the right is something called a fjord. And you might not know what the word fjord means, but what it is an inlet of sea that goes in between some cliffs. And this is usually not in America, it's in places like Norway and Iceland and stuff. So if you look at it, it's a lot smaller than the ocean, right? Does anyone else see any differences between these two things? Maybe there's more land in the fjord picture.
Mm-hmm.
And so these are walls. It has walls. It looks like it has walls from the mountains, you're right. So these are two places where tsunamis can happen. And what we're going to try to find out is what's the difference between the waves in each. And maybe how big tsunamis can get. Both. Would it be bigger in an ocean or would it be bigger in a fjord? And before we test that out, we're going to learn about how tsunamis work, because I'm not really sure of that yet, so I think we're going to watch a video about how they work. So if you would look up at the smartboard again, we're going to watch a TED Talk called How Tsunamis Work.
In 479 BC, Sea when Persian soldiers besieged the Greek city of Potidaea. The tide retreated much farther than usual, leaving a convenient invasion route. But this wasn't a stroke of luck. Before they had crossed halfway, the water returned in a wave higher than anyone had ever seen, drowning the attackers. The Potidaeans believed they had been saved by the wrath of Poseidon. But what really saved them was likely the same phenomenon that has destroyed countless others, a tsunami. Although tsunamis are commonly known as tidal waves, they're actually unrelated to the tidal activity caused by the gravitational forces of the sun and moon. In many ways, tsunamis are just larger versions of regular waves. They have a trough and a crest, and consist not of moving water, but the movement of energy through water. The difference is in where this energy comes from. For normal ocean waves, it comes from wind. Because this only affects the surface, the waves are limited in size and speed, but tsunamis are caused by energy originating underwater, from a volcanic eruption, a submarine landslide, or most commonly, an earthquake on the ocean floor, caused when the tectonic plates of the Earth's surface click, releasing a massive amount of energy into the water. This energy travels up to the surface, displacing water and raising it above the normal sea level. But gravity pulls it back down, which makes the energy ripple outwards horizontally. Thus, the tsunami is born, moving at over 500 miles per hour. When it's far from shore, the tsunami can be barely detectable, since it moves through the entire depth of the water. When it reaches shallow water, something called wave shoaling occurs. Because there is less water to move through, this still massive amount of energy is compressed. The wave speed slows down while its height rises to as much as 100 feet. The word tsunami, Japanese for harbor wave, comes from the fact that it only seems to appear near the coast. If the trough of a tsunami reaches shore first, the water will withdraw farther than normal before the wave hits, which can be misleading and dangerous. A tsunami will not only drown people near the coast, but level buildings and trees for a mile inland or more, especially in low-lying areas. As if that weren't enough, the water then retreats, dragging with it the newly created debris, and anything or anyone unfortunate enough to be caught in its path. The 2004 Indian Ocean tsunami was one of the deadliest natural disasters in history, killing over 200,000 people throughout South Asia. So how can we protect ourselves against this destructive force of nature? People in some areas have attempted to stop tsunamis with seawalls, floodgates, and channels to divert the water. But these are not always effective. In 2011, a tsunami surpassed the flood wall protecting Japan's Fukushima power plant, causing a nuclear disaster in addition to claiming over 18,000 lives. Many scientists and policymakers are instead focusing on early detection, monitoring underwater pressure and seismic activity, and establishing global communication networks for quickly distributing alerts. When nature is too powerful to stop, the safest course is to get out of its way.
Alright, so thank you for watching this video. It was really informative, and I think it answered a lot of our questions that we've had so far about tsunamis. So now what we're going to do is we need to conduct an experiment about how to test the difference between wavelengths of oceans and fjords. So what you're going to do is break into your small science groups, and we are going to write our own experiments. And so we need some ideas about what needs to be included in the experiment that I'm going to write up here. Do you have any ideas about what we need to include?
We need, what are we trying to find out?
Yeah, what do we need to know?
The purpose.
Purpose, right? Purpose, and I'll let you guys come up with your own ideas for what these might be. I think we also need a hypothesis. Does anyone know what a hypothesis is? I think it's a question.
It's a question.
Or a
A
theory.
statement about what you think is true.
Hypothesis. What's something else that we might need to add in our experiment? Do we need a plan?
Yeah, we need
Steps.
a plan of how we're going to test our hypothesis.
So I'm going to say plan with steps. And then what happens after we conduct with the plan? I think we need some sort of reflection.
Yeah.
reflection. And then after we have our reflection, we're going to come back together as a class and present our findings. And after that, we can maybe make some revisions to our hypothesis. So, we're going to write maybe, we'll make a new hypothesis about what actually happened. So, after we make our experiments, we're also going to graph our findings as a class. So if you look over here on the board, we have what type of graph written?
Bar graph.
A bar graph, exactly. And what we could do is we could measure the waves on one side. This is just an idea, you don't have to do this. And maybe drop a few items in the water. So if you look up here, we have 2 tubs of water that you're welcome to use. One is a little bit bigger for an ocean, and one is a little bit smaller for a fjord. And we also have many objects up here that you could try dropping in there. Or if you want to try to simulate an underwater volcano, you could do that. So we brought some rocks, some little Hot Wheel cars, some clay, some dinosaurs, and a few other objects that we can use to measure the wavelengths. And this experiment is going to be happening tomorrow. And also on the board, we have a little diagram. Do you want to explain what you drew?
Sure. So one of the things that we want you to measure in your experiment is the difference in the size of the waves in whether you're testing the ocean tsunami or the fjord tsunami or both. We need to know what's the difference between the two. That's kind of what we're trying to find out. So when you measure your waves, a wave is a waving line. So how do you know what to measure? We want you to measure from the crest to the crest, or if it's easier for you to see, the trough to the trough. But measuring from the bottom to the top, the trough to the crest, isn't an accurate measurement. So you need to pick one and measure from trough to trough, or crest to crest.
And these are terms you should remember from our video that we watched.
Yeah.
So what you're going to do now is write your experiments, and we're going to gather back again tomorrow to conduct our experiments, and we'll have all the materials again at that time. So go ahead and write your experiments, and good luck learning. Okay, class, so now that you've written all of your experiments, and now that it's the end of class, we're going to come back together and fill in the final portion of our KWL chart, the what have we learned portion. So I need some ideas about something that we learned about tsunamis. It might be from the video or some other knowledge that you might have. Do you have any ideas?
They happen in large bodies of water, not small bodies of water.
So I'm going to write large bodies of water. So they probably could not happen in ponds.
No.
Let's see if we can answer the other question we asked. We asked, how did they happen? Does anybody remember how they happened?
From a landslide.
A landslide, you're right. So it kind of happened from a landslide, or an earthquake, or just other disturbances. Maybe one more thing that we learned about tsunamis? I think that's probably not. Let's put what we learned about doing experiments. And this might be something from experiments. Something that you just learned.
We need to write in a lot of details in our steps so we know what to do.
Detailed steps. Because if they're not detailed, your data might be skewed at the end of the experiment, right? Another question we asked was, why do we do them? Why do we experiment?
We need experiments to test our hypothesis.
Yes. So we can have accurate findings and a research hypothesis. And hopefully we'll have a good hypothesis come tomorrow of the difference in wavelengths between fjords and oceans. So that's about it for today. Thank you.